This conference will now be recorded.
The EAD, that the EAD database or the base of the accounts for the EAD model will be a subset of the probability of default model data, right? So from there, what we are trying to do is we are trying to develop the we are trying to understand how is it that the model design for the exposure at default models would be. So first of all, the basic point from where we start off our discussion is what exactly is the EAD? The EAD is nothing but the exposure at the default. So this is the total amount to which the bank is exposed to at the time of default. So we have that exposure at default, right? Now this product for which we are developing the EAD model is the QRRE product, or a qualifying revolving retail exposure. Now, given that we are developing the model for a QRRE, so obviously one of the most important questions that comes out over here is that there are two types of balances. One of them is the on balance sheet balance, the on balance sheet item that is there, right? So one is the on balance sheet. The on balance sheet item. The other that we have over here is the off balance sheet item. So the second item that we have over here is the off balance sheet item. So over here we have these two things. Now the on balance sheet item is the one. So this is nothing but the balance that you have already drawn, or the drawn balance. Okay. So over here, what we have is the drawn balance, right? Now, from the off balance sheet, if I am to talk about the off balance sheet item, is the one which is the undrawn balance or the headroom, is the headroom. So your headroom is your undrawn balance. Undrawn balance, right? Now, if there is an undrawn balance, so what is this headroom? The headroom is nothing but the limit minus the balance, right? So this is how you define your off balance sheet or your off balance sheet exposure. Now the chances, now there is always a chance that the account, once it starts going delinquent, so just before it defaults, what it does is it draws out the money. So it draws out the money before. So limit mine. So obviously the balance. So basically, what you do is, okay. So as I was saying, so now there are these two balances, right? The one or the undrawn and the drawn. So it is always a possibility that before you go into default, what you do is you draw out the remaining balance and you enter into the next important question that comes out is that how do I consider this headroom or this undrawn balance into my model? So obviously, I need to have some kind of a conversion factor or some kind which will kind of help me convert this headroom into a on balance sheet equivalence. And that conversion factor is your CCF. So CCF is nothing but the credit conversion factor. So it is this factor which will help to give me the on-balance sheet equivalence of the undrawn balance of the headroom. We have the credit conversion factor, right? Now the question is that how do I calculate this on credit conversion factor, and how do I calculate the exposure at default? How do I get the observed values of the CCF? That is one of the important questions. So, so the EAD in total or the observed value of the exposure at default in the next 12 months will be is the balance plus CCF into the head. So now over here, the EAD over here is now CCF over here will be your exposure at default that you have minus the balance. The balance is nothing but the observed values of the balance by the head. So this is precisely going to be your CCF. Right. So the exposure at default minus the total exposure minus the balance divided by the headroom is your CCF. So this CCF shows, so what is EAD? The total exposure that you have. So now the question is, how do you calculate the exposure, to which I'll just come. So from there, I'll subtract the balance. So what does this particular part show? It shows the total exposure that is there minus the balance. So that means that's the remaining is that exposure due to anything else apart from the used balances divided by the available headroom. This becomes your CCF, right? Now the question that comes out is that CCF is used in different ways, or this difference EAD minus balance. So what does this difference show? Shows that out of the total exposure at default, the total exposure that you have. So from there, if I'm subtracting out the balances, apart from the balances, what are the other values that you have? So that is the future set of values that you have from there, right? So divided by the headroom. Now the question is that how do I define this CCF over here? Now EAD itself is unknown to me, right? Because my target variable is CCF, the credit conversion factor, which is nothing but EAD minus balance by headroom. So the only information that is available to me is the headroom, or the one that I have is the headroom, which is the limit minus the balance. So now I need to define this CCF over here first, right? So that is one of the most important objectives. Now from there, there are two possibilities which can happen. Now this CCF obviously belongs to the fractional set, which is 0, 1, right? So over here, what I want to do is I want to find out. So if I'm trying to find out the credit conversion factor, I want to find out that at what rate has the particular person be using the credit from the snapshot to the time he went into default. So let's say, now why am I calculating the CCF? So I'm trying to convert that undrawn balance to the drawn balance. So what I'm trying to do over here is I'm trying to identify the rate at which, the particular person draws or makes additional drawings from the snapshot to the time when he defaults will give me an idea about the rate at which someone would, or on an average the rate at which the portfolio can draw between the snapshot to the time to default, right? So at the snapshot, all the records are non-delinquent, so they have a usage, they have used a certain amount and there is a outstanding balance, and in the performance all of them have default. So what I'm trying to find out is that from the time, from the snapshot to the default point of default, what has been the rate at which they have used that undrawn balance, right? So that as a percentage of the headroom will be my CCF. It will be the rate at which that undrawn credit is getting converted into the on balance sheet credit, right? So, or into the drawn credit. So I need to find that EAD minus the balance is that rate. So balance is the balance at snapshot. EAD is the total exposure. So EAD minus balance shows the additional drawing that the person has done from the snapshot to the time of default, right? As a percentage of the headroom. So if I try to interpret this concept of CCF in a different manner, what I am trying to tell you is the following. So what is the CCF? The CCF is nothing but, if I have to interpret CCF, CCF says it is the rate at which the rate at which the rate at which the on balance, the off balance sheet item off balance sheet balance or the undrawn balance converts itself converts to on balance sheet items. To on balance sheet items. So over here, one thing that we need to do is we have the rate at which the off balance sheet balance converts itself to the on balance sheet balance. So I need that rate. Now, if you see the EAD minus the balance, now EAD is recorded at the date of default. So recorded at the default date. Okay. Now is record, so the EAD is the balance, our total outstanding balance recorded at the default date, and the balance is recorded as on the snapshot date. At snapshot. So the EAD minus the balance shows the additional drawings that the person has done, right? Before, before the default. So from the snapshot to the date of default, additional drawings that has been done. Additional drawings that has been done. So this is how you first define your target variable. additional drawings to it has come up to the additional drawings to default. So on one hand, we have the reported at snapshot, the additional drawings. So this measures the additional drawings to the default, to the point of default, right? Now the to the to default means from snapshot to the date of default. So when I say additional points up, additional drawings up to default, what I mean to say is so what I want to kind of say over here is that from default snapshot to right. Now one thing is that for the exposure at default base, you would have all the accounts, so all the accounts which are non-default at snapshot but have defaulted in the performance. So the time between that gives you your additional drawings to default. So this is how the CCF is defined. Now, however, over here there is one point which is which is kind of a issue. Now, at the denominator, while defining the CCF, you have the headroom. So obviously, the headroom is nothing but the limit minus the balance. So when the balance tends to the limit, right? The headroom tends to 0. The headroom tends to 0. So what I have over here is as balance tends to limit, the headroom tends to 0. And when headroom will tend to 0, CCF will tend to become undefined. So it is very important that this headroom condition is further investigated. So this headroom tends to 0 is further investigated. So this headroom tends to 0 gives us two possibilities. One is a case of low volatile usage, low volatile customers. So who have sufficient distance between, who have a sufficient headroom. And the second that I have over here is highly volatile. Is highly volatile. Now there can be some customers who have used up their limits. Right? So they have used up their entire almost a major part of their limit, and they have and the other that you have is a low volatile customer. So we have a low volatile customer and we have a high volatile customer. So for the low volatile customers over here, the low volatile customers over here are those customers who have sufficient headroom, for whom the EAD minus balance or additional drawings up to default by headroom uh, can be probably defined with respective to the the headroom balance. But high volatile customers are those customers who have a balance to limit which have a headroom tending to zero. Now, if the headroom becomes very small, then CCF will automatically become volatile, right? So we need to ensure that, so this is one check which has to be done. That is the distribution of the headroom such that after a point it becomes very volatile. Now this is one of the most important checks that we need to do, right? We need to actually assess that whether, so is it the case that after a point of time of usage, after a point of time of headroom usage, the variable becomes or it becomes highly volatile. So so this is one of the checks that we need to do, right? So this is a very important analysis, assessing that which is that point, is there a switchover point from where the utility, the headroom becomes extremely volatile. So that the headroom tends to zero. Now, if the portfolio is such that there are not much of a very high intense users and that the the headroom has not gone immaterial. So when I say 10 to 0, what I mean is the concept of immateriality. So is there a case where the headroom literally becomes immaterial? That has become immaterial, then you cannot use the headroom as the denominator. So what is that value below which the headroom becomes immaterial? So that is a very important analysis. And what we need to show is, and we need to check that after that point, so after the headroom becomes, if the after that headroom balance or the headroom just that value, the CCF suddenly becomes very volatile, right? Or the CCF distribution suddenly becomes very volatile, and that's where the definition of CCF has to be split. So that switchover point, so does there is the headroom distribution such that after a point of time the impact falls on the CCF distribution and the CCF distribution becomes very volatile? Does that kind of a value, does an immaterial value lie, allow for the headroom balances? Right. So any questions up to this point?
So CCF would be the target variable for EAD, you're saying.
Yeah. So CCF will be your target area.
But this is for QRRE. Then for term loans, uh, for a straight line, what do you like? What would be the target variables for this?
So it will be the observed yield, the future value of the total balances minus the paid installments plus the future value of the unpaid installments. So that
The cash flows.
yeah, the future value equation that we discussed. So that will be the observed yield. So the only difference between a term loan and a QRRE product will be that the CCF will be zero. So you will not have any headroom. So that total balance, the balance that you would have, right?
Strong balance.
I mean, the future value of that balance will be the exposure rate.
So whatever there is on the on balance is your EAD. Hello.
Sorry, sorry, yeah, tell me.
So whatever is your drawn balance is your EAD. In
No, for personal loan, there is nothing such as undrawn and undrawn balance. Right? So in a personal loan, when you apply for the loan, you get that whole loan.
hmm,
Right. So out of that loan, you are paying your EMIs every month. When you
right.
pay that EMI every month, and let's say after a certain date, you get, I mean, you default, right? The account defaults,
Hmm,
right?
right.
So when the account defaults, so there are two things that comes into account. The first is that there are some balances which you have already paid. So what I need to see is the following. Number one is what is the future value of this outstanding balance? To this, I need to adjust all unpaid installments. So that is the amount which has not been paid, as well as the interest and everything which accumulates on that. And then the next thing that we look into it over there is the amount that has been paid, or the some of the amount often gets paid. So what is that future value of the amount which is getting paid? So the difference between the three is your exposure reduction.
So one is the future value of your unpaid EMIs. One is the future value of paid EMIs, and third one is
All the future value of all the other charges that you have.
or the charges on or the interest. Okay.
So those three will give you your total exposure at default that you have.
We do that straight line amortization, no, in these term loan cases, right?
Yeah, you use a statement amortization. So when you are doing the future value calculation, so what you are doing is you are actually amortizing that.
Okay.
Okay. So I'll come to that formula. I'll come to that formula. Okay. So now the question that comes out over here is that I have this headroom and I need to understand that how volatile is this headroom. So is the headroom really volatile or not? So I need to know how is that the distribution is looking like. So over here, so one of the questions that we need to address corresponding to the headroom over here is that I have the headroom over here. So the question is, So the question that we are kind of asking over here is that does there exist so does there exist a value such that the, the CCF distribution becomes volatile? Distribution becomes so this is the key question that we need to answer. Now, if there is a value which makes this distribution volatile, then you know that this is there exists a value which is an immaterial headroom. Does there exist any such value? Is the question, right? So now the question that I would like to ask over here is that what do you think that how do you think can we capture the volatility in the CCF distribution? So how can I say that the volatility has suddenly or the distribution has kind of suddenly become volatile? How will you do? So how do you think or how can you capture whether the volatility become or the CCF distribution has become more volatile due to the distribution of the CCF, I mean of the headroom? Think about it. So take 2 3 minutes time to think about it, frame it in your mind, and then give me an outline of that analysis that you frame. I have an answer over here. So Pritam says that by comparing past utilization and utilization default, okay, how do you do that? So over here you have your headroom distribution, and from there you're calculating the CCF. You get a CCF distribution. Now you want to find out that beyond which value, after which value, is it that the CCF is becoming more volatile? If there exists such a point, then what you will do is you will just know that okay, so if the utilization less than this, then I'll have a separate definition for CCF because I can if I use headroom, then what it means is that I cannot so my headroom becomes very small, so I cannot use it. Otherwise, CCF becomes unnecessary unstable. So is there such a point or not? So how can you assess or how can you analyze? It would be great if you can give me the steps, possible steps that we can take, or you can give me a broad logic of this. Okay. So first of all, try to understand the fact that the distribution of the headroom is what that is the assessing the distribution of the CCF, right? Now, if the CCF becomes volatile, so what it means is that after certain level, you will see. So you will see that the overall variance in the CCF will increase suddenly, right? So basically, the first thing that you need to do is, or the steps that you would follow to do this analysis is very simple. So first is divide the headroom into different bands, into different size. Divide headroom into D size or different groups or categories or into equal groups, I would say. So from that perspective, decile is a more appropriate aspect, right? Headroom into deciles. Into deciles, right? So the next thing is after this has been done, the next thing that I'll do is I'll calculate the I'll calculate the CCF for each of the deciles. So the entire distribution of CCF for each of the deciles. So calculate the distribution of the CCF for each of the deciles. Of CCF. So divide. So what I'm going to do is I'm going to talk about the distribution of the CCF for each deciles. Okay. So distribution of CCF for each deciles, and for each of these deciles, what you are going to do is the following. You are going to compute the mean and the standard deviation for each of the deciles. Mean and the standard deviation. Standard deviation, right? So now what will happen is with each of the group, what you have done is you have actually calculated the respective standard deviations. Now, what you will see is that the variable becomes volatile. The variances of sudden, so if you take on a rolling basis from one side to another, if you look into the value, and if you do a rolling sample, so you take the standard deviations and to find out the standard deviations of those standard deviations, you will suddenly see that after a point of time, the second order has suddenly started increasing. So the standard deviation increases at an increasing rate. So in such a case, you know that the series has kind of become volatile, right? So the third step in doing this is plot the standard deviations across the descents. Plot the standard deviations across descents. Standard deviation. Now what we'll do is we plot the ST across the deciles. So how does the graph now look like, or how would it look like, or kind of look like over here? Say so we have the deciles over here. And we have the standard deviations over here. Right. So what I'll do is I'll just plot a simple histogram of the standard deviations over here. So let's say this is how the standard deviation is over here. Over here, let's say it's something like this. It's something like this over here. Suddenly what you see is it takes off. After this point onwards, the standard deviation increases and it increases at an increasing rate. So you know that once when the account has, or when I have hit this decile, the riskiness in the model has, or the data in the model has increased. So this is where the riskiness is. So suddenly what you see is that the standard deviations have increased, and not only that, the standard deviation of the standard deviations have also increased. So the riskiness has increased. Right? And from there, you know that the volatility problem has right. So from this cutoff, we'll see that if there exists such a thing, then what we do is we say that okay, after this point, this distribution CCA becomes extremely risky. So what we'll do is we will uh, so what we'll do is we'll kind of not be uh, so we'll not be using the headroom from this or there on, because this will make the CCF very, or it will make undefined or make it more volatile. So what we are going to do is we are going to use a alternate definition. So in that case, so accounts for accounts which are, so in that case, what happens is your CCF definition gets divided into two parts. One is a CCF1 over here in this zone. So as long as the headroom is below this value, I mean, is more than this value, right? So as long as it's more than this value, then this is CCF1. And when the riskiness happens, actually, when the standard deviation is less than this value, it is CCF1. When the standard deviation is more than this value, it is CCF. Right. So the CCF definition or your CCF1 definition over here will be your additional drawings before default by headroom. So I'll call this CCFA. This is your additional drawings prior to default. Prior to default. Prior to default divided by headroom. And so after that cutoff value, right? So if when the headroom falls below a critical value, I have the second definition, which is the CCFB. CCFB is additional drawings prior to default by limit. It is additional drawings prior to default additional drawing prior to limit. So these are the two alternate definitions. So these are the two alternate definitions of Basel model that we have of EAD. So basically both these two are fractions, right?
How does CCF-B is different from CCF-A?
Tell me how it is different. See, you have a look into the formula. So what is the denominator for CCFA?
Headroom.
What is the denominator for CCFB?
There is no headroom.
No, what is the denominator?
Okay, okay, it's a limit. Okay, fine. I thought it's slash. I thought slash. So it's slash.
Yeah, so slash is divide. So it's slash
Right.
is divide. Yeah. So so the CCF, so because the headroom becomes very less and it tends to zero and the CCF becomes very volatile. So from that point onwards, you break the definition into two parts, right? So this is how the target variable is created for the EAD. Now the next question that comes out is two things.
So CCFB is your when riskiness arise, right? When it became
Yeah.
volatile, right?
So CCFB is once this happens. I wrote CCF1 and this is A and this is C. So in this part, once it becomes volatile, then you have the second CCF. So is this analysis clear? I mean, you guys clear with this idea why we are creating these two definitions?
Yeah.
Fine. So now, after we have created the target definition, now there is another important thing that we need to talk that we need to think, that there is always an immateriality issue. So let's say when an account defaults, right? You see that the exposure, let's say an account has closed its card and that there is a very small balance which is outstanding. Now, do you consider that borrower as default? So, after what level of value will I actually consider a person to be a default? Like above what value? So, there is an immateriality analysis. And the second question, and the next question that comes out over here is that during this process of analysis, during the, so let's say I'm standing at the snapshot and I have a limit, right? And what happens is that the person in the next month, the first month, the performance goes a limit increase, right? He's given a credit limit increase, post which he goes and defaults. So how do I treat the increase in or the changes in limit increase? So if there has been a change in the limit, in the credit limit, how do I adjust for? So these are the next thing that we need to do, because this definition of the exposure and default, the materiality analysis of the exposure, the EAD values, and this second one that we're talking about, that we are kind of talking about over here, these two are kind of, so they are kind of prior to each other. I mean, these two will be kind of with it. I mean, with one another. So they will be in kind of sync in kind of one another. So in this sense, So the choice of the immaterial EAD and to take into account the impact of the line increases is important, because that will determine the value of the exposure at default, or it will help us in calculating the value of the balance outstanding, right? So, or for example, the headroom. So if I'm stand at my snapshot, I have a headroom of with a limit of 50,000, but in the next 1 month it has been increased to 10,000 by to 16,000. So now I have 10,000 more dollars. So how do I treat that? So how do I treat line increases? So in the part of model design, these are the two questions. Number one is the materiality analysis of EAD. Second is the treatment of line increases. So these are the two last adjustments that we talk about under EAD, right? So we now know how the data is. So how do the data for EAD has to be fetched for model design, and now we also know that how is it the target variable has to be created. Now, while creating the target variable, for creating the target variable, these two are the next two are the two nuances that we need to keep in mind, right? Now, with that, we finish the model design for the EAD. So, what are the accounts which are contained in EAD? So, the accounts which contain the EAD is or the EAD model are those accounts which are active as on the snapshot but have defaulted in the performance. And what is the target variable? The target variable is the CCF. Now, for to calculate the CCF, the headroom plays a very critical role in the denominator. And over there, we need to understand whether it's a volatile or a non-volatile case. Now, based on that, the two definitions for CCF are created and the target variable is thus created. However, it could also be the case that the exposures of some accounts are kind of so some of them have immaterial exposures, and some of them may have gone through line increases. So how do we treat them? How do we incorporate those changes when creating the target variable? So that will finish the discussion for EAD. So we discuss that part tomorrow, and from there we move on to talk about the LGD model designs, right? So we have the PD model design, we have the EAD model design. The third that we'll talk about is the LGD model design. So with that, we'll complete the model design portion in tomorrow's discussion. So, but before that, go through this recording, and if you have any doubt, please do ask. Thanks a lot. Good night.